So let's get started with first law of thermodynamics. Basically, this is one of the ways that I describe law. This is what I tell my students. This is an energy auditing law. Thus, that is, given a system, energy will come in, energy will go out, right? Changing the internal energy of the system. So basically, it keeps track of the energy coming in and energy going out. That's all it does. So that's your first law. So as an obvious thing, it states that you cannot create energy. So energy cannot be created, nor it can be destroyed. So it can be converted from one form to something else. So that's what the law states. And in terms of formulas and idea, given a system, I can figure out the internal energy of the system by looking into E in and E out. Right? So how all can we put energy into the system? Remember, it has to be in terms of heat and work. Right? Heat and work. Energy can go out of the system with heat and work. Energy can come into the system with heat and work. Right? So heat in or work done on the system, heat out or work done by the system. So the first law gives us a formula. The formula is delta U is equal to heat minus work. And to reflect this, we have sign convention. So we have to take Q as positive when there is heat coming into the system. And obviously Q is negative when heat is going out of the system. So let me just use a single color. Yeah, Q is positive when heat is coming into the system and Q is negative when heat is going out of the system. W is positive when we have, since it's minus W is positive. Again, minus W is for the formula. W is an individual term, right? I hope you guys understand that. So when W is positive, it is work done by the system. When W is negative, it is work done on the system. So negative of negative becomes positive and delta U increases. Again, it's a sign convention. You just have to follow that. If the formula was something else, this convention would have been something else. So basically, the system is able to gain energy over here and over here. And over here, it is going to lose energy, and here too, it will lose energy. So this is your sign convention. Okay, so you guys have to keep this in mind. Right? So this is your first law, as simple as that. So let's see the write-up if there's anything to be added or if I missed anything. Okay, one more picture, which is what I missed. One more way of talking about all of this. I'll just explain that part. So what I've done over there is I have a, say, energy line, okay, an axis. So this is an energy axis. Right represent system gaining energy. System will gain energy over here. Here the system will lose energy. If the value is negative, it will lose energy. So there is energy loss. So if we have, let me put it this way, if we have, say, energy or heat coming in, right? So this is Q1. And if the system is doing work, so we have to move to the left. So work by the system. If the energy coming in is lesser than the work done by the system will lose energy. Right? This is one possibility. Like this, there are many possibilities. If I take this and yeah, in this case, the energy that the system is getting and the work done by the system, again, they are not equal. The work done by the system is lesser than the energy gained by the system heat coming into the system. So basically, the system will gain energy. In this case, the system will lose energy, right? So that's the representation. So left of 0, system is losing energy. Right of 0, system is gaining energy. If the work is done by the system, then it will move left. If the work is done on the system, the work will be right. For example, let me do this again. So if the system is losing energy, this is Q out, and the system is doing, or if the work is done on the system, it will be a arrow pointing towards the right. For example, if the work done on the system is lesser than the energy it loses in the form of heat, then the system will be losing energy. Overall, the system is losing energy. So that's all it represents. So I think there are a few more possibilities in this manner. So that's it. Yeah, I think I'm done with introducing first law. Just a small introduction. So first law is an energy auditing law. The currency that we deal with is work and heat. The core idea is that the internal energy of the system changes when heat is added or removed, obviously. If the work is done by the system and on the system, again, obviously. So this is a rough diagram. So we have a system, energy can come in or go out. Energy can come in when heat is added to the system or work is done on the system. Energy goes out when heat is removed or work is done by the system. A possible scenario, an example scenario. So you have system gaining energy in the form of heat and it's losing energy by doing work. If both are positive, and then the energy gain will be a lot more. The formal statement is that energy cannot be created nor destroyed. It can be transformed or converted from one form to another. The thermodynamic version is that the change in internal energy of a system should be equal to heat added minus work done by the system. So this is one of the ways of putting across the formula. Of course, the official formula is delta U is equal to Q minus W, where delta U is change in the internal energy, Q is the heat added to the system, W is the work done by the system. And of course, we have the sign convention that we need to know. If Q is positive, heat is added, or you have to take Q as positive when heat is added, and Q will be negative when heat is removed, or heat leaves the system. Actually, you can't remove it. There's no remove concept over there. It leaves the system. Technically, it's that. When work is done by the system, it is positive. When work is done on the system, it is negative. So that it will reflect this formula. Basically, it's because of that. The formula is taken so, and so the convention. And delta U, of course, it's positive when you have the internal energy increasing. Negative if the internal energy decreases. Okay, so you guys can copy whichever you like, whichever version you like.